Hello and welcome to this video. In this video we're going to be looking at expanding brackets. So expanding brackets is a very key skill in solving any problem really. Expanding would be the opposite of factorizing, so maybe if you want to expand your expression to be able to simplify it a little bit and get a nicer expression, we could do that. Expanding brackets is also part of the BIDMAS or BODMAS, so whenever you're actually going to solve any arithmetic questions, you might also have to expand your brackets as well. So let's see how we do it. So we could start with an expression that would be 2x plus 1. Okay, and what this would mean is that whenever we have these brackets, it just means we have a little multiplication sign in between them. So we have to multiply whatever's on the outside by everything on the inside. But we do them one at a time, so we'd multiply the 2 by the x to get 2x, and then we'd multiply the 2 by the plus 1, which would give plus 2, and this is your expanded formula. We could do this with more algebraic things like this, but we do the same thing. We'd do 3x times x would give you 3x squared, and then 3x multiplied by 3 is going to give you 9x. And this is your expanded formula. We could do it with even more algebraic, put in a few more letters and numbers. Let's say we have 2xy goes into y plus 7, maybe. We'd do the same thing. Don't let the letters scare you. All we're going to do is do 2xy times y. The 2x stays the same, but the y is now going to be squared. And then we multiply the 2xy by the 7. The 2 times 7 gives you the 14, and the x and the y stay the same. And that would be your expanded brackets. But these are all when we only have one bracket. We could possibly be given quadratic brackets. So let's have a look how we would go about solving the quadratics in this case. So if we have quadratics, we usually put them into two brackets. So we might have x plus 3 multiplied by x plus 5. And they might ask you to expand these brackets and get a quadratic expression. And the way we're going to do this is exactly the same way we've done this. We're just going to take everything here. So we're going to take the x and multiply it by everything in here, and we're also going to take the 3 and multiply it by everything in here. You have to be careful with these, however, because we can sometimes forget to multiply one by the other, and so we have a little acronym that might help. We have FOIL, which stands for the first, the outer, the inner, and the last. So what this means is the first thing I do is I multiply the two things that are first in either of the brackets. So that becomes x times x, which gives me x squared. Then I do the outer two, so this one on the very outside and this one on the very outside. So x times 5, which gives me plus 5x. Then I do the inner two, the two on the inside, which gives me plus 3x. And then I do the last two, the ones that are last in both the brackets. And that gives me plus 15. Now, you can probably tell I can simplify this middle section here because they both have an x in it. So I can simplify that to give me x squared, and 5 plus 3 is going to give me the 8x plus 15. And now this is expanded. So let's try one more. But let's make it a little bit more complicated. So let's have a 2x plus 1 multiplied by an x minus 3, for example. We follow the exact same algorithm or formula or method. We do the first two, which is the 2x times the x, and the 2x times the x gives me 2x squared. Then I do the outer two, the 2x times minus 3, which gives me minus 6x. Then I do the inner 2, which is 1 times x, which just gives me plus x. And then the last two, which is 1 times minus 3, which gives me minus 3. And again, I can always simplify these two in the middle. And if I have minus 6x plus x, it becomes 2x squared minus 5x minus 3. 3. And this is your expanded brackets. And this is the extent that you'll have to know, but I want to push this a little bit further for those trying to get 8s and 9s. Maybe we want to practice by trying to expand 3 brackets. Maybe we can go even further and say, what if we have x plus 5 multiplied by x minus 2 multiplied by x plus 3, maybe. So now we've got 3 brackets. So this is very high end, almost pushing onto A level, but I just want to show that it's really not that different. So if we wanted to expand this, I would say cut off the last one and just expand the first 2. And that's exactly how I've been doing this. It's just by FOIL. So we do the first 2, which is the x times the x, so we get x squared, multiplied, then the outer 2, so x multiplied by minus 2, minus 2x, then the inner 2 plus 5x, and then the last 2 minus 10. But this is all going to stay in brackets for now, because we're still going to have to do that by x plus 3. But we can simplify this in here. We can get x squared. This is going to become plus 3x minus 10. And that's going to be times by x plus 3. Now, notice we don't have a first, an outer, an inner, or a last now, because we have this plus 3x in the middle. So what we're going to do is say, let's do everything multiplied by x. So we'll do the x squared times x gives you x cubed. The 3x times x gives you plus 3x squared. And the minus 10 times x gives you minus 10x. Then we can do everything multiplied by 3. So 3 times x squared gives you plus 3x squared. 3 times 3x gives you plus 9x. And 3 times minus 10 gives you minus 30. And now you can simplify this, because x cubed, we only have 1x cubed. Here, x squared, we have 2x squareds. So that becomes 6x squared when we add the 3x squared plus the 3x squared. Then the minus 10x plus the 9 is going to give you minus x, and then minus the 30 at the end. So we can even expand triple brackets in the same way, just by recognizing what brackets are doing. We're multiplying everything in the first bracket by everything in the second bracket. Now this last part here is a little bit extra for those who want to push themselves. For most students, you can just focus on having the knowledge of expanding these single brackets and these double brackets, and that will suffice. Okay, so this is expanding brackets. Thank you for watching. Hello and welcome to this video. In this video we're going to go through some expanding brackets practice questions and hopefully consolidate all of our understanding on how we expand brackets. So let's start with this first one. These questions are going to start off easy and slowly get more and more difficult. So with this first one, we've said that brackets, we just treat them as a multiply, but it means that we have to multiply everything on the inside by whatever's on the outside. So we need to do the 3 times the 2y, which is going to give us 6y, and we need to do 3 times the minus 5, which is going to give minus 15, and then we have our expansion. Nice and easy. Okay, now let's use that, but make it a little bit more tricky by just having 2 sets of single brackets. So we're going to do the same thing for each one first, and then we're going to simplify it afterwards. So if we expand it, let's just take the 3x minus 4. And this, I need to multiply everything inside by 3. So if I multiply the x by 3, I get 3x. And if I multiply the minus 4 by 3, I get minus 12. So this is my first section. And then my second one is 2x plus 5. And so I need to multiply 2 by the x, which gives me 2x. And I need to multiply the 2 by the plus 5, which gives me plus 10. Now what they're asking is we need to minus these 2 things from each other. And so to do that, we're going to put them together. So 3x minus 12 minus, and I'm going to put this in a bracket here and you're going to see why. So 2x plus 10. And that's because we're minusing this whole thing from this. which means if we were to leave it as just 2x plus 10, we'd end up actually adding 10 onto this, whereas we want a minus 10. So I would say, just as a caution, put both of these things in brackets. Okay, now the first one doesn't really matter too much because we already know its sign is out here and it's an invisible plus. However, for the second one, it is important to put this brackets so that you're minusing the whole thing here rather than just minusing the 2x and then adding on a 10 afterwards. So what this means is we have to do, if we expand these brackets now, this is like saying we have an invisible minus 1 out the front. And so we have to basically just make both of these things negative if we wanted to minus the whole thing. So it would become 3x minus 12 minus 2x minus 10, because if we were to expand this, it would bring both of these two things to be negative. And now we can simplify. We bring both our x's together because they both have the x term in them. That's going to give us just x, because 3 minus 2 is just going to give 1, and we don't have to really write the 1 there. And minus 12 minus an extra 10 is going to give us minus 22. So this is our simplified formula. Now let's try and look for some more quadratics. So we've said for quadratics we have these double brackets, and we want to expand them with the method of FOIL, making sure that we're multiplying everything in this bracket by everything in this bracket. So we said FOIL stands for first, then outer, then inner, and then last. So let's draw this a little bit bigger so we can annotate it. So we've got x plus 4, x plus 6. The first two are the x and the x because they're the first ones in both of the brackets. So if I multiply x by x, I get x squared. Then I do the outer two, the one on the furthest outer side of this and the outer side of this, so x times 6, which gives me plus 6x. Then I do the inner two, which is 4 times x, which is plus 4x. And then I do my last two, which is the last ones in both of the brackets. So 4 times 6, which gives me 24. And now, as always, I can bring these two terms together, and 6 plus 4 is going to give me 10. So I have 10x plus 24, and that is our expanded brackets. The simplify in this question just comes from pulling these two terms together. As soon as we pull those two terms together, that's your final answer. Now let's push a little bit further. This is a very difficult question because we don't only just have 2 brackets, we actually have 3, and we're trying to prove that if we were to expand these brackets, then this is what we would get to. Okay, so let's, like we said before, we're going to just cut off the last bracket and work with the first two. So if we were to expand 3x minus 1, x plus 5, we'd use FOIL again. And with that, we're going to do the first two. So 3x times x gives me 3x squared. The outer two, so the 3x times the 5 gives me plus 15x. The inner two, so the minus 1 times x gives me minus x. And the last two, which is minus 1 times 5, which gives me minus 5. And now I simplify this. So it becomes 3x squared. And the plus 15 minus the x becomes plus 14x minus 5. Now I'm going to put this back in brackets because remember this is all still going to be multiplied by this 4x minus 3. We said we can no longer perform this FOIL because we have a term in the middle. So if we do the outer and the inner and the last, we're going to actually miss out this 14x. So what we're going to do instead is we're going to take this 4x and multiply it by each of the 3 terms in here. So we're going to do 4x times 3x squared first. And I'm going to write that up here. So the 4x times the 3x squared is going to give 12x cubed. Already looking like we're on the right track. Then 4x times 14x. So 4 times 14 is 56. So and the x's will multiply together as well. So this is going to become 56x squared. Then we do 4x times the minus 5. That's going to give minus 20x. And then we also have to then do the minus 3 times the 3x squared, which is going to give minus 9x squared. Then we do the minus 3 times the 14, and 3 times 14 gives you 42, so minus 42x. And then we do the minus 3 times minus 5, which is plus 15. Now we can simplify this. So the 12x cubed, there's no other x cubes in this expression, so that stays by itself. So we write 12x cubed, 56x squared, and 9x squared. If we did 56 minus 9, we'd get 47. So we get plus 47x squared. And then we look for everything that's just x's. So minus 20x minus 42x gives us minus 62x, which is also what we want. And this number plus 15, we don't have anything else that's just a number. So we just plus 15. And this is our proof. We know that now that if we just expand the first two, we get this expression, but this expression has to be multiplied by everything in this. And when we do that, we expand it, we pull together all of the like terms, so everything with an x squared, everything with an x, everything with an x cubed, and everything that's just a number, and then we get to this final expression, which is exactly what we were expecting to get in the question.